glad to have you here. I'll be honest, the sessions that we have this morning at breakfast and at lunch are the ones that I've been looking forward personally the most. And part of that is that for the last few years, I've served on the board for our local affiliate of Habitat for Humanity. And you'll get to hear a little bit more about that story at our lunch session. But we've been using prefabricated components for our builds since COVID. And it's really been transformational in what our affiliate has been able to do and how it's been received by the community. And so our goal today, you'll see we've kind of got two parts. We've got this morning session, which is about incremental utilization. So how do you start dipping your toes into using this? And then at lunch today, we're going to talk about, okay, are you ready to go all in, whole hog into this? So we have a lot of the same panelists across both of them. Before we do introductions of our panel speakers today, I'm curious how many of you here in the room have already started to dip your toes into using prefabricated components, modular. Okay. Yeah, so we've got a few of you. I'm curious, for those of you that haven't, to kind of give us a framework so that we can see what concerns we need to address today. What is it that has kept you from using this in the past? And if we can get the microphone ready here, just for any of you that are willing to share, what is it that has kept you from dabbling in using prefabricated components and panels in the past? So we'll start right here.
We're down in Southwest Florida, so wind codes and insulation requirements mainly. We use block construction, so if there is prefab components out there that can meet those needs, then we would love to look into it more.
Okay, we can address that. What else? Other concerns or questions as to why you have not started to dabble in prefabricated components? Anyone else willing to share? Yes, over here.
So we're in Atlanta, and pretty much everybody who's done it in Atlanta has done it unsuccessfully. Companies come in and out. I did it in Charlotte for a couple of years.
Can you elaborate on what unsuccessful looked like for them?
Not having the right trade partners.
What was that?
Not having the right trade partners.
Not having the right training partners, okay.
Yeah, we did it in Charlotte. We had framers fighting with 84 lumber, no consistency. One of the biggest issues we had was if the slabs weren't correct, they're out there with sledgehammers beating things into place.
Okay.
And we just did not find, we didn't save the time that we were should, because you're going to pay more up front. If you're not saving the time, it's kind of useless. We just could not make it work with the trade partners we had.
Okay, good. I think those are useful points of reference. Anyone else willing to share what might have kept you? Or I think this is a good example. If you've seen others in your markets who have tried, what didn't work for them that maybe you're like, yeah, I'm going to pass on that. Okay, I think that's a good start. Something we can work with today, right? Okay, so let's as we turn over to here, let's do introductions of our wonderful panel we've got today. Now, I will put an asterisk here. You'll see that we're missing one individual here, and they're not joining on pre-recorded. Michael Gibson in the bottom right is actually a fellow faculty member of mine at K-State. He's worked on the Habitat for Humanity project that I was just referencing. He wasn't able to be here for the whole conference. His intent was to fly in last night, and of course, as luck would have it, his flight got pushed back, and so he's on a morning flight. He's going to miss this morning, but he should be here for lunch. So we'll get to catch up on some of his input as a professor of architecture. He'll certainly be able to talk about some of the design challenges, but probably more what the foundation you need to put in place. But with that as a foundation, let's begin with Dave. Can Dave tell us about yourself and about your company?
Hi, good morning, everybody. My name is Dave Stevenson. I am the sales manager for InsulSpan structural insulated panels. I actually have two roles at the company. One is sales manager, but with my construction background, I find myself on the job site a lot doing site advisory services. And anyhow, InsulSpan manufactures SIPs, structural insulated panels. We have two locations, one in Blissfield, Michigan, and the other just up the I-5 here across the border near Vancouver, British Columbia. So it was an easy trip down here for me today. That's what we do, structural insulated panels.
Okay, next on our panel, Jason.
Hello, Jason Carter with Vantum Global. We manufacture a similar system. It's a SIPS, but I like to use the term SIPS on steroids. We have a non-combustible, waterproof, fireproof, nano ceramic SIP. We built about 3 million square feet in South America. We recently received an investment from Breakthrough Energy Ventures, a $1 billion fund created by the Bill and Melinda Gates Foundation to lower the carbon footprint, and they chose us as a housing solution. Our goal is to build 15 factories here in the United States with partner developers. Glad to be here and hope to answer all your questions.
And last up, Ken.
My name is Ken Pinto. I own a supply chain consulting firm called Kenzai USA. Kenzai is the Japanese word for building materials. In Japanese language, Ken means construction and Zai means products. I was born for this, right? So after decades of being a manager of construction, both commercial and residential, I discovered that not having the right materials in the right place at the right time was prevented me from improving my construction operations. And so I got out of operations with intent to go into supply chain, fix that, and then I'd go back into operations. I vastly underestimated the size of that task, and I'm still in supply chain. And so much so that I last 12 months ago, I wrote a book, How Much is the Milk, which is a supply chain management book specifically for residential construction. The only one of its kind. There should be dozens of books like that in our industry, but there isn't. There's only one. I'm not sure why a carpenter like me had to write it, but I had to write it. So, and as a matter of fact, I brought this with me, and so those who ask the best question will get this book today. This is a little giveaway for today. Very subjective process in which we will award someone a book signed by the author. And I started using wall panels and roof trusses in 1979. So when I was a junior in high school, I built 5 houses my last 2 years of high school. And Latham Lumber Company in Sacramento, California, was making wall panels. And I don't know if they were the first to do it, but we didn't know of anybody else who was doing it. And boy, we sure built those houses fast.
There are some benefits. So to start off, we're going to talk a little bit about what do prefab panels, SIPs look like, and there's certainly a spectrum. The pictures you see here come from the build at our local Habitat for Humanity, where the prefab panels were done by Kansas State students under Michael Gibson's tutelage, where the panels are put together and then brought to a site about 5 miles away, and then the panels were lifted. And I've got some more pictures and videos that we'll see at lunch for this particular build. But as I show these photos to Dave, he looks at it, he's like, that's nothing like what our SIPs look like. And then when you look at what Jason's company is doing, really doesn't necessarily look exactly like what Dave is looking at. So I want to give everyone here a chance to talk about kind of their flavor, but really what they are, how they're made, and then we'll start talking about some benefits and stuff. So we can kind of work our way down the table. Dave, you want to start off?
Sure. Well, what do prefab panels look like today? I guess in terms of how they looked yesterday, there's a lot more technology going into the panel manufacturing process now. Most of the panel design is with 3D CAD modeling. Those CAD drawings are then programmed into a CNC cutter, and the panels are typically cut with CNC fabrication techniques. So they've come a long way over the last, say, 10 to 20 years. The panels do look different depending on the manufacturer and the type of panel. We do what are called typically what most people would refer to as SIP panels, stress skin or structural insulated panels. It's just really 2 layers of sheathing inside and out with a insulated core laminated to the sheathing, and then those panels are cut on a Hundegger PBA machine that to any shape or size and sent to the panels to be tilted up and clicked together.
And when you say sheeting, what is the sheeting?
In our particular case, we use 2 sheets of 8x24 OSB sheathing on the interior and exterior side of the panel with a EPS core. That core can be of various thicknesses, and there's 2 types. There's the regular type 1 EPS that most people would associate with a SIP panel, just that white EPS core. More recently, they've begun to infuse carbon, basically carbon into the foam to increase the R value. It comes out looking almost dark gray or charcoal, and is referred to sometimes as neopore or GPS foam.
Okay. Ken, tell us a bit about your experience with talking about SIPs. What of the ones you've worked with look like, and was there anything you'd want to add specifically to what Dave described?
I've never made a panel, but I have bought a lot of panels. And so from the acquisition side of the business, there's a few reasons why we want to do it. One is speed to market. All right, so you want to reduce the construction cycle time. You can do it with houses. Let me give you an example. So when I was with Pulte Homes, we built a community in Southern California called Sun City Shadow Hills. 5,000 houses in that community. And so we had our framer set up a panel plant, which we invested with him on that, significant investment. Pretty short distance drive, which is a key part of this panel business, from the manufacturing plant to the job site. And when you have 5,000 houses to build it all in one plant, you can make a lot of money with that speed to market as well as the efficiency of getting those panels done. And quality is another issue. Quality is a big one. I mean, I'm old enough that I've been on job sites now for more than 4 decades. And I can tell you that the quality of craftsmanship in the field is not getting better. My hat is off to all the organizations that are striving to take high school graduates and teach them trades. And my hat is off to them. I applaud the effort, but I don't have confidence in the effort. There's not enough people in those programs to be able to support what we're going to need over the next 10 years. You know, you look at the number of people who are in our industry who are craftsmen who are going to be retiring over the next 10 years, and there's no solution for backfilling them. So I think that we look today at panels as an option. From my perspective, I don't think it's going to be an option. I don't think there's going to be, I don't think you're going to have a whole bunch of framers who are going to be available to frame your houses 10 years from now. So it's looking pretty doomed. So not only the availability of the labor, but the quality of labor is really going to be tough. And when you have factory-made panels, your quality level just soars. If you want to show a homeowner the difference between a house that was made with panels in a factory and one that was framed in the field, just walk them into one framed house and another framed house, and instantly they're going to see the difference. So the precision of the way that things go together, they're going to be like, oh, wow, that's different.
Okay. Jason, tell us a bit about what you guys are manufacturing. I think I've got a slide here that kind of shows some of the construction as well.
Thank you, Dave. I don't want to talk too much about the hog, but I hope all of you come to the next panel that we're going to have. It'll really be cool, showing where I think the future will go and what we're going to try to do to position changes in the construction workforce, but it is struggling. So the Vantum panel is a low carbon panel. It is very similar to a wood SIP, except we've removed the wood. We don't want any wood on the product, wood burns, wood chips, and if anyone's ever, to the gentleman at the first table there, talked about not being able to get the wood SIPs to fit, you're right. You got to work those things in and beat them, and that kind of goes against the speed of what you're trying to do. Whereas the Vantum panel is CNC'd as well, but it's a nanoceramic, so it's very light, very hard, and very accurate when it comes to fitting those together. So you can see the panel there. It's a good example and representation of really, as an industry, what SIP really does for the framer. It eliminates a lot of steps in the process by delivering a very high energy envelope. And we are about energy. Let's not mistake that. Vantum, and I'm sure SIPs in general, you're using SIP because you want to have low energy, right? You don't want to spend a lot on your utility bills. Vantum's whole model is about lowering the carbon footprint. When you build a 2,000 square foot house with our system, we have an 85% lower embedded carbon footprint. Our envelope is phenomenal. It doesn't mold, so if a house floods in our next session, we'll show you some examples. We've put, again, 3 million square feet of this product around the world. We'll be penetrating the U.S. here very quickly and be opening up factories, so you'll be hearing about us more. But we are energy focused, building housing at a very low carbon footprint, heating and cooling them on a dime, which SIPs in general will do if you use a good envelope.
All right, so getting to I think I've got some good photos here. So this is again from our build. You can see that the panels were loaded up on the left onto a trailer. Then we had teams showing up the morning of, moved all those panels around the foundation, which was done. The foundation had, I don't know exactly what the correct term is for it, but basically straps that were embedded into the foundation that then loop up over onto the panels. And they were able to basically get the framing up and airtight in 2 days. It's pretty quick.